The key ingredient in the lubrication system of the engine is, unsurprisingly, the lubricant itself. This is engine oil or motor oil, it's the same thing. And this is a lovely fresh new engine oil ready to go into an engine. And in this jar we have the old engine oil that came out of this engine at the time when we take it to pieces. And I lovingly kept this, knowing that we could show it now and talk about the difference. So you can see an immediate difference. The new engine oil is a lovely golden colour and you can see through it. The old engine oil is dark, and that's because it's full of impurities, of contaminants, all sorts of nasties that circulate around in the engine. The job of the engine oil, though, is to become this dark colour, because the oil wants to carry these contaminants around the engine and not deposit them onto surfaces. So the detergent in the engine oil is designed to keep these contaminants in the oil and remove it when we change the oil in the engine. The other thing is that just because the oil is dark colour doesn't necessarily mean it needs to be changed, because as soon as we pop this fresh oil into the engine, within a few days this will also be a dark colour. Let's get rid of this old engine oil and talk about the good fresh stuff. So engine oil, motor oil, oils generally are lubricants. And a lubricant is a liquid which reduces the friction between two moving surfaces. So as two surfaces rub together, that causes friction, which creates heat, as you'll know when you do this. And that heat is a waste of energy. So the energy that goes into moving two parts, be it rotating surfaces like the crankshaft on the bearings, we want all the energy that goes there to go into generating movement. We don't want to waste that energy in heat. And that is exactly what friction creates. It takes the movement between two parts, takes that kinetic energy that we're hoping to use for propelling our car forwards, and instead of propelling the car forwards, we're just generating heat, which is not what we want. So the purpose of a lubricant is to reduce friction. And any liquid can be a lubricant. For example, if you were to be on a water slide, then the water is the lubricant. That water gets in between the slide and your bum, and you rapidly slide down the slide without friction or with minimal friction. And the thing with a water slide, just like an engine lubrication system, is you need a constant supply of that lubricant, because as soon as you sit on a water slide and the water stops, the water underneath you is squeezed out to the sides, your bum is in contact with the plastic, and you're there wiggling your way down like this, which is not what you want. So with a constant supply of water onto the slide, there's no friction, you slide all the way down to the bottom, and it's a wonderful time. Just as in the engine, we need a constant supply of lubricant to keep those parts separated and reduce the friction. Any liquid can be used as a lubricant. In fact, we could use water inside the engine as a lubricant, but that would be a terrible idea, because water causes parts to rust, whereas the oil actually prevents rust of components, so that's helpful. Water also is a lot weaker in terms of being forced out from underneath things. So essentially water is less slippery than oil, and we know that if you pour oil on the floor and walk on it, it's extremely slippy compared to water. Also, if you were to slide down a water slide, for example, and you poured some oil onto that slide, you know that would almost certainly take you all the way to the bottom of the slide, because that oil wants to stick together and not be forced out from underneath you, whereas the water very easily just is pushed apart. So that's another thing in its favour. The other thing is water evaporates, and so that water will disappear if used as a lubricant, particularly as it gets warm, whereas oil does not evaporate, or is far less evaporative than water, and has a much higher boiling point, so it can take the heat much more easily than water. So the main function of the engine oil inside the engine is to reduce friction. We already talked about friction being this conversion that we don't want of kinetic energy into heat energy. And friction is affected by basically three different parameters. So we have the materials themselves. We know that rubber as a material has more friction than, for example, a smooth stainless steel. We just simply know that as common sense. So the type of material dictates the amount of friction between two surfaces. We also have the surface finish. A very smooth, polished surface has less friction than a rough, cast finished, rough surface. And the third is the amount of load pushing those two surfaces together. So if you have a light object, for example, resting on a surface, there's less friction between those two than if we have an extremely heavy concrete block. There's innately much more friction the heavier something is. So the friction is determined by those factors. So having discussed those three properties that determine the amount of friction, we can see why some things are designed the way they are. So the bearings and the bearing surfaces inside the engine are always polished very smooth and made of a low friction material. And in order to reduce the load which is pushing two surfaces together, for example, the crankshaft is supported in 5 different places in this engine because the crankshaft is heavy. If we can spread that load across 5 surfaces, we have less friction. And of course, we're pumping the engine oil in between those bearings to lubricate between those surfaces. Because with the lubricant in there, the friction is reduced almost to 0, which is exactly what we want. Another consequence of surfaces rubbing together is wear. So no matter how polished and smooth those surfaces are, there's always going to be an abrading between the surfaces as microscopic, rough, raised areas and ridges on those materials bang into each other. That causes tiny fragments of metal to chip off and chip out, leaving behind a rougher finish, and gradually those surfaces wear and we end up with a rough surface, obviously increasing the friction as it goes. Another one of the oil's functions inside the engine is to cool the parts that it flows over. So heat is generated inside the engine and that heat wants to be carried away, and the heat can be absorbed into the engine oil, and the engine oil then makes its way around the engine, carries that heat away, drops down into the oil pan, sits in the oil pan and is cooled by the passing air underneath as we rip along the highway. That's another function of the oil, is to cool the parts that it flows over. You may have heard of the grade of an engine oil, and the grade of an engine oil is a measure of how viscous that oil is. Viscosity, the viscousness, if that's a word, how viscous a liquid is a measure of its resistance to flow. So the grade of an engine oil is a measure of its resistance to flow. We can demonstrate that using this sloping surface here. In this demonstration I've stolen from an old geology teacher. This one's for you, Mr. Vivers. If we pour this engine oil down here, this has a grade of 20. It's a relatively viscous engine oil. We can see how quickly that moves down the slope. This is a much less viscous, more runny engine oil with a grade of 5, and we can see immediately that flows much more easily down the slope. That's a less viscous oil. It has less resistance to flow. And an extremely non-viscous liquid would be this blue cocktail liquor, which I found. There we go. So to sum up grades of engine oils, before I clear this mess away, the grade of an engine oil is a measure of how thick the engine oil is. Essentially, it's resistance to flow. And that grade is given by the Society of Automotive Engineers. It's an SAE grade. And that's going to be a number generally between 0 and 50. 50 is a very viscous, very thick engine oil. 0 is an incredibly runny engine oil. Maybe the same consistency as this delicious blue liquor. So just remember, when you're looking at engine oil grades, 0, 5, those are very runny, very thin engine oils. 40, 50, those are extremely thick engine oils. Early engines used thick engine oils, and as engines have improved in engineering, clearances have tightened, and manufacturers have gone for efficiency, engines have trended towards thinner oils. So you'll find that old engines use a thicker, higher grade engine oil, like a 30, and a modern engine will use a 5, a 10, or even a 0 engine oil. But things are a little more complicated because engine oils become thinner as they get warm. So they lose viscosity at higher temperatures. And in the winter, the engine can be sitting at minus 15 degrees centigrade. And in the summer, it may well be sitting at 30 degrees centigrade. Those are big differences in temperatures, and the viscosity, the thickness of the oil is going to change. So in early days with engines, they would use 2 different oils, one for the winter, one for the summer, unless you lived in Costa Rica, where the temperature's 20 year round. However, most of the world we have different temperatures, winter and summer, so they would use different engines, and you would change your engine oils in the spring and the fall. In about very early on, oil manufacturers developed what's called a multi-grade oil, which is an oil which has an additive which enables it to change its viscosity a lot less over variations in temperature. So you will find all modern engines use a multi-grade oil, and that means we can use one oil for the entire year. And the grade of an engine oil is therefore specified as two numbers. The first number is the viscosity of that oil at sub-zero temperatures. So in our case, we have a 5W40 oil here. 5 is the SAE grade in the winter, which is why we have a W. So that's 5W being an SAE of 5 in the winter. 40 is the grade that this oil behaves like at normal temperatures during the summertime. So you will find that oils for your engine are specified as this sort of multi-grade specification. 5W40, 10W40, along those lines. Now we can know, taking this to a practical level, what happens if you use the wrong oils in an engine. If the oil's too thick, it's viscous, there's a lot of resistance to movement inside the engine, it will be less efficient, and the oil pressure will be higher because it takes more pressure to drive viscous, high-grade oils around the engine. Likewise, if you use too low a viscosity, the grade of your oil is too low, then that will be forced out from between the bearings and you could end up with metal-to-metal contact. That's why engines use different grades of oil, because the manufacturers have looked at the characteristics of that engine and said, this engine requires an oil of a certain viscosity in the winter and the summer, and this is what we should use. So that's engine oils. This is just a random oil that I found on the shelf. If any big oil manufacturers want to send me some bundles of cash in order to pimp your oils out, then I'll be more than happy to do that. Just send me some cash and some oil and some cake, and we'll get the job done.